Hello everyone, I'm back with a video about direct variation. And I'm going to get right to it. Put very simply, direct variation is something you'll encounter in algebra and can also be represented geometrically. Direct variation is just when one variable increases, so does the other, just as I've written there, as you can see. And that's basically the easy way to describe what's happening with direct variation. So some other things to go along with this to help clarify is that there's a nice formula for direct variation, that y equals k, and that's highlighted in orange for a reason, x. So this is y equals k times x. And k, it just means the constant of variation. So anytime you have this formula involved, you know it's going to be a direct variation. Okay, so let's talk about some examples really quickly to help clarify this concept. First one, given y varies directly as x. So just off of that statement right there, I know I'm going to be working with this equation right here because it tells me that these two variables vary directly. Okay, so I know I can go ahead and write that equation. Y equals kx. And they give me some other information. Y equals 5, x is 20. They want me to find k, and they also want me to write the equation after I do that. Pretty easy to do. All I have to do at this point is say, okay, I'm given that y equals 5. So what I can do here is replace y in this problem with 5. So this is going to be 5 equals. I don't know what k is, so I can leave it as k. That's what I'm trying to find. And I know what x is, it was given to me as 20. So I'll just put in parentheses times 20. Now, I can very quickly solve for k by dividing both sides by 20, and I'll have an answer for k. So when I divide both sides by 20, I'm going to get that k, and I'll write k first over here, is simply going to be 5 over 20, which when I reduce that will become 1/4. Okay, now that I know my constant of variation, this, and it's okay that it's a fraction, it's okay if it's just like, say, 7 or, 1 or something like that, that's fine. Now that I know my constant of variation, I can go ahead and write the equation and I'll be done with this problem. I know my y values, my x values, and my value for k, so all I have to do is say that y will vary 1/4 as much as x. And that is the equation for the direct variation given these parameters here and here for y and x. And for that problem, that's all you had to do. All I had to do is find k and then plug it back in, and this gives me the equation that they're looking for in this problem. Y is equal to 1/4 x. And then I can pick any values I want for x and y and see what I would get and plug them right in here. But this is all they wanted us to find, and we're done. Okay, next problem. In the same spirit, if y varies directly as x, so just off of that line, I can automatically start off by writing the equation that's associated with direct variation, y equals kx. And y equals 30 when x equals 20. Find y when x equals 12. Okay, this is a similar problem, even though it might seem a little different. So what I'm going to do first is figure out what my value for k is. That's the thing about direct variation. K will always be the same. So let's go ahead and find what k is, and then we can go on from there. Okay, so I can use this information here. I know that y is 30. I know that x is 20. So let's see what I get. Okay, plugging in 30 for y, and I get that this is going to be k times 20. Just replacing x and y with the values they gave me here for x and y, and I get this line right here. Now I can go ahead and solve for k just like I did in the previous problem by dividing both sides by 20. And when I do that, this becomes essentially just 3 halves. You can cancel the common zeros out in fractions, and you get that your constant of variation, your value for k, is 3 over 2. Okay, so I'm going to use this value for k, and we're going to plug in to now find y when x equals 12. Okay, so since I'm trying to find y, I don't know what it is right now. So I'll go back to my equation, I'll rewrite it. I don't know what y is, we will find it by the end, but I don't know it yet. Set this equal to k, which I just found, is 3/2. And I can do this because no matter what x and y are, they're going to change, in this problem anyway, according to this, with a constant of 3/2. So I can go ahead and plug my value for k that I found in. And they told me, okay, when x equals 12. So I'll just do 12 here because that's where the x goes. Okay, so now when I solve this problem right here, all you have to really do is multiply the top number by this right here. So 3 times 12, 12, 24, 36. So you get this, y equals 36. And then you have this divided by 2 left over, so go ahead and put divided by 2. Okay? And to solve this, you just get that it's 18. That's a sloppy 18. Sorry about that. It's supposed to say 18. Okay, so I have that y equals 18. That is exactly what they wanted me to find. So in this particular problem, when x is 12, I have a constant of variation of 3/2, which we found. Y turns out to be 18. Let me rewrite this a little cleaner. 18. And that is that direct variation problem solved. I hope this helps, and thanks for watching.